Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 42 in chapter 21. Chapter 21 is about electric charge and electric field length. So we can see we need to determine the magnitude and direction for electric field length at the point A and B in this system. So we can draw a picture for this system. We can see the left point charge is we call it Q1. The right point charge we call it Q2, right? They are with the same charge. Q is given. And also at the position A, we draw a picture look like this one. If we wanted to find the electric field at the position A, we can see first one, the electric field come from the Q1, right? So we write it as the E left, right? And also the electric field come from the Q2, so we write it as E right. And both E left and E right are vectors. If we want to find the addition for these two vectors, we can project the E left, E right in the X component and the Y component. Agree? We can see this angle, we call it theta. And so we can see for this one, this is angle theta, right? This angle just equal to this angle. Agree? And this angle equal to this angle. So these two angles just equal to theta in these triangles. And then if we know this is theta, so you can say we can project the E left in X component to E left times cosine theta. And then in Y component becomes E left sine theta. Similarly, we can get it projected the E right in X component and Y component, right? So this is E right cosine theta, E right sine theta. Now, next question, how can we find theta? So we can see in this triangle, the side length is for this part is 0.05. The side length for this part is 0.1. Therefore, we can get theta as arctangent 0.05 divided by 0.1. You get answer there. Now, next one, can you find the magnitude for the E left and E right? Yes. This is just determined by the Coulomb law, right? K times Q divided by the distance squared. So the distance from the point charge to the A, D, you can find in this triangle. So this side squared plus this side squared, so you get answer there. Agree? So therefore, we can write the E left and E right in vector format. Say in the E left, so this side length, agree? Plus, so this X component times I, unit vector, plus the Y projection in Y component times the J component. So you write it there. The next one, you can write the E left vector in X component and Y component. There, the E right cosine theta pointing to the negative X component, so we add the negative side there. So in unit vector I component, in J component. Now you can see you need to find addition for these two vectors. You just add the X component together, add the Y component together. You just get the 2K, Q over D squared sine theta. See, this term and this term cancelled, right? Now you can see in this equation, K is a constant, Q is given, D is we find it there, theta is we find it there. So you input all the known quantity, you get answer there. So similarly, very easily you can see this magnitude for the electric field is found as this number, right? The direction, it is pointing to the J component, so pointing up. Y component, agree? Now we look at the position B. So for position B, we can see similarly we can write the electric field from Q1 as E left, right? And the electric field from the Q2 as the E right. Still, we projected the E left and E right in X component and Y component. By there, we need to take attention. this angle called theta left, and this angle equal to this angle. Agree? Yes. So there we project. So E left cosine theta x component, E left sine theta left to the y component. Similarly, I'll change the color. This angle theta left equal to this angle. Agree? So then we project the E right in x component in y component. Next question. How can we calculate theta left and theta right? Easy, right? So first one, we look at the theta left. So the side length for this one, 0.05, and side length for this one, 0.05. So we can get theta left as arctangent, 0.05 divided by another 0.05, 45 degrees. Now we look at theta right. You can see it equals to arctangent 0.05 divided by this side length, and then we get answer there. We put it there. And also, if we need to write the magnitude for the electric field, E left and E right, we use the key Q divided by distance squared, right? So now we need to find the distance D right and D left. So first we look at the D left in this triangle. So we use this side squared plus this side squared, and then we get answer there. At this triangle, we can get the D right as this side squared plus this side squared and squared, we get answer there. Therefore, we can write the magnitude for the E left and E right in these two equations by applying Coulomb law. Agree? And then we write them in the x component, in the y component. So in vector format for E left and E right. Agree? Similarly, we need to pay attention there. The E left project in x component pointing to negative directions. So we must add the negative side at there. Right? Yes. Next step, we need to add these two vectors together. So you can see we add them together. The equation looks like this one. And in these equations, you can see K is a constant, Q is given, theta left, theta right, and also the D left, D right is given. So the Ri, we input all the known quantities. We get answer as this one. And you can see now the electric field at position B is in the vector format. We can get the magnitude and angle theta in this way in these two equations. Thank you.